بسم الله الرحمن الرحيم والصلاة والسلام على سيدنا محمد صلى الله عليه وسلم. Inshallah, today we will begin a new series on the YouTube channel. It's called Building a Greener Future. In this series, we will discuss the relationship between structural engineering and sustainability, and how structural engineering can benefit the environment. In session number 1, we will discuss the sustainability assessment of fly ash concrete. This session is presented by Engineer Asim Atif, an assistant lecturer in the Structural Engineering Department in Zagazig University. As an introduction, at the present moment, we are living in a climate emergency. As is very visible to every person in this world, and every person in this world is affected by this issue, climate change causes a lot of problems such as floods, wildfires, droughts, and other environmental impacts. The main cause of the climate change is the effect of the greenhouse effect. The greenhouse effect is caused mainly by greenhouse gases that include CO2, CH4, and N2O. But mainly, CO2 is the most responsible greenhouse gas in the greenhouse effect, as is the most common greenhouse gas. The greenhouse effect causes the surface temperature of the Earth to rise with time. Scientists predict that at the end of the 21st century, if we do not make some serious changes about our environmental behavior, we will reach a rise in the average temperature of the Earth's surface by about 2 to 6 degrees Celsius. So we are running out of time. There is no time left to make an environmental action to reverse this serious problem. Some solutions: the United Nations in 2015 introduced some of the most important and pivotal actions to reverse the climate change. They agreed that by 2030 we will achieve about 45 CO2 reduction, and by 2050 we will reach net zero carbon, such that the amount of carbon dioxide we emit, we will reduce its impact by using renewable energy and other strategies, so that we will reach net zero carbon. This is a common responsibility between all fields and all specialties. In civil engineering, we can benefit this strategy by using sustainable structural design. To understand the importance of sustainable structural design, we need to see first the construction impact on the environment. According to the United Nations Global Status Report, construction contributes by more than 37% of the carbon dioxide emissions worldwide, at more than 34% of energy demand worldwide. Especially the steel industry. The steel industry alone contributes by more than 2.5 trillion kilograms of carbon dioxide per year, which represents about 25% of the total CO2 emission worldwide. The question is, can we minimize this figure? Can we reduce the carbon dioxide emissions worldwide? The global objectives that the United Nations have put, and Egypt had adopted these goals in its vision for the 2030. The United Nations specified 17 goals, which the United Nations called the Sustainable Development Goals. These goals aim to achieve sustainable development in all the fields, such that by 2050 we will reverse the climate action effect, and we will reach net zero carbon. From these 17 goals, the main goals that structural engineering can contribute to include decent work and economic growth. In addition, industrial innovation and infrastructure, as well as sustainable cities and communities. Finally, responsible consumption and production. We have a limited amount of resources in this world, so we have to be responsible in its consumption and production. But how? How to achieve these goals? One of the possible solutions to achieve these goals is the use of green building materials. Green building materials are those materials that are eco-friendly, that are less harmful to the environment. These include recycled aggregate concrete. Recycled aggregate concrete is made by demolishing old structures, old reinforced concrete structures, and using the waste materials by crushing it and making it as aggregate in new concretes. Fly ash concrete. Fly ash is a byproduct of the combustion process of coal, which is used to produce electricity in power plants. So this fly ash can be used as a cement replacement in concrete, as we will discuss in this session. Timber is used as a sustainable construction material, especially in the US and Canada, as the amount of trees there is large and can be used as a building construction material. But as it's well known in Egypt, the trees are not so commonly available, so it may not be a sustainable material for construction in Egypt. Ultra high performance concrete is a novel material that's being used in the structural engineering field, which requires a less weight of concrete. So we will use less cement that will help the environment and reduce the environmental impacts. Other sustainable materials are continuously developing and can be used in the future, and we will discuss more materials in future sessions. All these materials have lower carbon emissions, which means they are more sustainable. Fly ash concrete is the main subject of this session. In this session, we depend mainly on this paper that has been published in Renewable and Sustainable Energy Reviews journal, which is a prestigious journal in the field of environmental engineering, and it's called Life Cycle Sustainability Assessment of Fly Ash Concrete Structures, and it has been published in 2017. As an introduction, cement is considered the second most used material worldwide. The first most used material is water. For each ton of cement produced, we need about 3.1 up to 5 gigajoules of energy to be consumed to produce 1 ton of cement. For each 1 ton of cement, about 0.73 up to 0.99 tons of carbon dioxide are emitted. So, as you can see, the cement has a very high impact on the environment. So we need cement replacement. One of the most commonly known cement replacement is fly ash. Fly ash is a byproduct of the coal-fired power plants and is considered the world's 5th largest material resource. This is mainly because of China that uses coal to power its power plants. So the amount of fly ash produced in the power plants is very large in China. It's about 700 million tons per year of fly ash. And the scientific research in using fly ash as a cement replacement in concrete is not recent. It's not a modern idea. It lasts for more than 50 years. But can fly ash be the solution for this problem of the environmental problem and climate change? How to judge the sustainability of a material? To judge the sustainability of a material, we need to consider the triple bottom line. Triple bottom line are 3 main factors that needs to be considered during looking if a material is sustainable or not. The first bottom line is called the environment. How much carbon emissions are emitted during the fabrication and transportation of this material. The economy, or how much does this material cost. And the final bottom line is called social performance. It means the impact of this material on people, like labor health. How to assess each of these bottom lines? To assess each of these bottom lines, we need life cycle assessment to assess the environmental impact, life cycle assessment, LCA, To assess economy or cost, we need life cycle cost or LCC. To assess the social performance, we need social life cycle assessment or SLCA. So that these triple bottom lines can be assessed accurately to determine if this material is sustainable or not. The methodology used in this paper, a small notice, this paper is an engineering paper, so some of these mathematical formulations you do not need to understand it, but you need to understand the basic concepts underlined in this methodology. First, we need to assess the environmental impact, economic impact, and social life cycle impact of this new sustainable material. Then we need to consider the service life. Service life. You can have an environmentally friendly material such as fly ash, but when using fly ash in concrete, the service life is reduced. So if we use a bridge with a reinforced concrete, it may have a service life of about 100 years. But if you use fly ash, it may have a service life of about 25 years. So this is not considered sustainable at all, and using ordinary reinforced concrete may be a better option. So they considered the service life as a factor in determining whether this material is sustainable or not. As you can see, they divided the social impact by the service life, environmental impact they divided by the service life, and economic impact they divided by the service life. They determined an environmental score and social score and economic score. Using these three scores, they calculated a sustainable value. This value is used to determine which alternative is more sustainable. Is it reinforced concrete or fly ash concrete? This is the basic methodology that is used in this research paper. As a quantitative assessment step, first we need to define the goal and the scope. Then we need to determine the life cycle inventory or LCI. Life cycle inventory is a database of materials that tells us that 1 ton of cement causes a production of about 1 ton of carbon dioxide. This is what is life cycle inventory all about. Then we need to perform life cycle sustainability assessment. As we mentioned, it's composed of 3 basic steps: life cycle assessment, life cycle cost, and social life cycle impacts. According to the British standards EN 15804, which is called Sustainability of Construction Works, the lifetime or the life of a structure can be divided into 5 stages. These 5 stages can be described as follows. First, the product stage. The product stage consists of 3 main stages: the extraction of raw materials, transportation to the factory, as well as manufacturing the materials. Then construction. Construction consists of transportation of the raw material to the site, as well as construction of the building. The maintenance and use stage. This consists of using the structure, maintenance, repair, replacement, refurbishment, energy use, and water use. End of life stage includes the demolition as well as transportation of waste materials. Transportation of waste materials can be transported for disposal in landfills or on waterways, or can be used for recycling. Then the final stage is beyond the life cycle, or after the building has been demolished. It can be used for reuse and recovery. These are the main 5 stages for any product or for any structure. If you consider the embodied carbon or carbon emissions from the beginning of the structural life up till the end of the structural life, this is called cradle to cradle, or من المهدي إلى المهد. From the moment the raw materials were extracted from the ground up to the point the material were recycled and inputted as a raw material again in a new structure. But if we considered only the region between the extraction of the material up to the manufacturing of the products, is called cradle to gate or من المهدي إلى البوابة. What we intend from this cradle to gate is the moment from the extraction of the raw materials up to the gate of the manufacturing plant. First, we define the goal and scope of 1 cubic meter of fly ash concrete. Then we define the system boundary as cradle to gate, meaning from the moment of extraction of raw materials up to the point of manufacturing and exiting the manufacturing plant. For the life cycle inventory, there are many options that can be used as the life cycle inventory, from which Athena, Chinese Life Cycle Database, EcoInvent, European Life Cycle Database, or Inventory of Carbon and Energy. This is one of the most famous databases that can be used as the life cycle inventory, but in this research, the European Life Cycle Database had been selected. How to calculate fly ash impact? First, you have to understand that fly ash impact or fly ash can be considered a waste material from the power production process. From burning coal as a source of energy, fly ash is a waste material. But fly ash can be considered a raw material for concrete production, as it can be used to replace a certain percentage of cement. Then, this equation can be used to consider the environmental impact of using fly ash. First, you have to consider it as a raw material for creating or producing concrete. Then you have to treat it as a waste material from the power production process. These are the factors that have been used in this equation. For more details about these coefficients, the paper have to be consulted. To make the life cycle assessment of life cycle sustainability assessment of the fly ash concrete, we have to consider the triple bottom line: environmental aspects, economic aspects, and social aspects. To consider the environmental aspects, human health, ecosystem, and resources have to be considered. For the economic dimension, cost of raw material, cost of fuel used in transportation, and cost of energy in the concrete preparation have to be considered. For the social dimension, living condition, medical treatment and health, as well as education, culture, and necessities. Necessities including food and clothes. As a case study, the researchers considered a pre-stressed concrete girder bridge. This is a graphical representation of the bridge. They studied the fly ash effects. They replaced a certain percentage of cement by using fly ash. When we use 100% of cement in the concrete, we're using 0% of fly ash. But if we used 25% replacement ratio of fly ash, then we use only 75% of cement in the concrete. By increasing the replacement percentage of fly ash, we reduce the embodied carbon, we reduce the embodied energy, but we also reduce the reinforced concrete strength, and we reduce the surface life of the structure, which may lead to reducing the sustainability of the system. Then the researchers considered 5 replacement percentages, including 0% representing ordinary reinforced concrete, then 20% replacement ratio, 30% replacement ratio, 40% replacement ratio, and 50% replacement ratio. Then, by investigating the case study without considering the surface life effect, they found that the results are as shown. For the environmental aspects, by increasing the replacement ratio of the fly ash concrete, we found that the environmental impact is reduced, which indicates that this is a positive effect of increasing the fly ash. When considering the economy, by increasing the fly ash replacement percentage, the cost is reduced, which also a positive impact. When considering the social impact, by increasing the fly ash replacement ratio, we reduce the social impact, which is a positive effect. We can see that when neglecting the surface life of the structure, we can see that increasing the replacement ratio of fly ash can improve the environmental impact, economic impact, as well as social impact. But by performing surface life calculation, by increasing the fly ash replacement ratio, we reduce the lifetime or surface time of the structure. As can be seen from this table, by increasing the percentage ratio from 0%, 20%, 30%, and more, the service life of the structure is reduced from 30 years, 28 years, 27 years, 25 years, 21 years for a replacement ratio of 50%. When the same case study is considered, but with considering the service life, we can see that by increasing the replacement ratio, replacement percentage of the fly ash in the concrete, at first the environmental impact is very high. Then it's reduced by increasing the fly ash up till a specific point, which represents the 40% replacement ratio. Then it increases again. Then the optimal replacement percentage for the social performance is 40%. But for the environmental performance, as can be seen, by increasing the fly ash replacement ratio, the environmental impact is increased. This can be explained by using of plasticizers or water reducers when using fly ash, such that to increase the workability of concrete. Water reducers have a very high environmental impact, which cause the environmental impact of concrete to increase, which worsen its sustainability performance with time. Finally, the economic performance. When increasing the fly ash replacement percentage, it first reduces till reaching the least amount at a percentage of 30% replacement. Then it increases again, which means that for the optimal cost or least cost, we have to use a fly ash percentage replacement of about 30%. Then a sustainable value is calculated for each case. As can be seen, for a replacement percentage of 0% indicating an ordinary reinforced concrete, it has a sustainable value of about 1.7. Then the sustainable value increases for the replacement percentage of 20. Then it reaches the maximum sustainable value for a percentage of 30%. Then it reduces again for a sustainable value of about 40%. Then the least amount when the replacement percentage of about 50%. As can be seen from this figure, the optimal fly ash replacement ratio is about 30%, indicating the highest sustainable value. For the conclusions, life cycle sustainability assessment have to consist from life cycle assessment to assess the environmental impacts, life cycle cost to assess the economic aspects, and social life cycle assessment to assess the social performance. We have also to include the technical performance aspects into the assessment by considering the service life of the structure. By increasing the fly ash replacement percentage, both environmental and economic and social impact is reduced without considering the service life. But when considering the service life, we have to consider other factors. And sustainability consists from the triple bottom line of the environment, economy, and social. For future works, uncertainty in the environmental, economic, and social impacts can be considered, as well as sensitivity analysis can be performed to determine the best parameters for reducing the sustainability impact. Finally, more data can be used to design the mix of the fly ash concrete. This is the end of our session today. Today we talked about using fly ash in concrete and is it a sustainable material. We concluded that by increasing the percentage of fly ash in concrete, it reduces its surface life, which may cause it to be a less sustainable option than using ordinary reinforced concrete. But this study, we concluded that about a percentage a replacement percentage of about 30% is the optimal value for using fly ash as a replacement for concrete, to consider both the environmental aspects, economic aspects, as well as social aspects. Thank you. See you in other videos. Assalamu alaikum wa rahmatullahi wa barakatuh.